Welcome to fractions and percentages. So a fraction is a ratio. That is, it is one quantity divided by another quantity. And in math, a fraction can be any ratio. But in science, the word fraction, or the term fraction, usually refers to a part of a larger whole. That is, a smaller quantity divided by a larger quantity, or a smaller quantity over a larger quantity. And this is a part divided by the total, the part divided by the whole thing. And this means that in science, a fraction always has a value between 0 and 1. So follow this rule for fractions. The fraction is quantity A divided by quantity B. And it usually equals, the fraction is a part divided by the total, so a smaller number divided by the larger number. Now, the decimal equivalent of a fraction is the value of the fraction written in decimal form. For example, 1 over 2, 1/2 is 0.5. 1 over 10, or 1/10, is 0.1. 3 over 4, or 3/4, is 0.75. And 5 over 5 is 1. Now, to find the decimal equivalent of the fraction, then divide the numerator by the denominator. So note that your calculator will usually default to displaying the answer in decimal form, but some graphing calculators can also display answers in fraction form, in which case you can switch between the two forms in the mode menu. Now again, in math, the term fraction refers to a number in fraction format, like 1 over 2 or 3 over 4, but this could also be something like 7 over 5 is a fraction in math. But in chemistry, the term fraction refers to the part of a whole, or part of a total. And thus in chemistry, we write such a fraction as its decimal equivalent. And again, note that in chemistry, a fraction must have a value between 0 and 1 because it represents a part of a whole. We can't ever have a part that is larger than the whole thing is. So a percentage is a fraction or its decimal equivalent multiplied by 100%. So if our fraction is 1/2, then its decimal equivalent is 0.5, and then 1/2 times 100% is equal to 0.5 times 100%, which is 50%. And this means that 1 is 50% of 2. So I want to make a note here that the percent symbol is a unit, just like centimeters or milliliters or pounds. And that means that you must write that percent symbol along with your number, just as you would for meters or grams or milliliters and so on. You cannot drop that percent sign because the number that you have, if you have, say, 50%, that's the same thing as 1 over 2 or 0.5. But you can't say that 50 is equal to 0.5. This equality is not true, whereas these top equalities are true, and that's only because we have this percent symbol there. Because essentially what we're saying is that 50% really means 50 per 100. Cent means 100, so 50% is 50 per 100. 50 per 100 is 50 divided by 100, and that gives us 0.5. So you have to include that percent symbol in there, otherwise you're changing the value. 50 is not equal to 0.5. So now let's look at how to convert between percentage and decimal equivalents. To convert a decimal equivalent to its percentage, we simply multiply the decimal equivalent by 100%. And this will result in the decimal point moving 2 digits to the right, and we have to include that percent sign. To convert a percentage to its decimal equivalent, we divide that percentage by 100%. And this will result in the decimal point moving 2 digits to the left, but we also are going to now have percent divided by percent, and so the units there, the percent, will now cancel, and so the percent goes away. So you should check. The number in the percentage is always going to be 100 times larger than its decimal equivalent. For example, to convert 0.075 from decimal format to percentage, we take 0.075 times 100%, and that gives us 7.5%. So we've moved the decimal point 2 digits to the right, and we've added the percent sign. To convert 85% to its decimal equivalent, then, we divide by 100%, our percent symbol, that unit goes away just as if we had meters over meters. And now we have 85 divided by 100, that gives us 0.85. So in chemistry calculations, we can define a percentage in three different ways. We can define it as percent is equal to a part divided by the whole, or the total, times 100%, or as the fraction times 100%, or as the decimal equivalent times 100%. Or we could define it as X percentage means X parts per 100 parts of the total. Or we could define it as X percent means the decimal equivalent parts per 1 part of the whole. So in percentage calculations, that 100 in 100 parts and 100% is an exact number. And thus, it does not affect the uncertainty. And thus, it doesn't affect the number of sig figs in our calculated answer. So remember that a percentage is based on a fraction. So when a percentage is wanted, use this rule. If a percent is wanted, first write the fraction that is wanted, and then find the decimal equivalent of that fraction, and then convert it to its percent. So in shorthand, if percent is wanted, then find the fraction, and then find the decimal, and then convert to the percent. For example, 25 is what percent of 400? First we write the fraction. We want a percent, so the fraction is part divided by the total, so part is 25 divided by the total of 400. And next, we want to convert that fraction into its decimal equivalent, so 25 divided by 400 is 0.0625. Next, we want to convert our decimal equivalent into percentage, so we have our percent is equal to the decimal equivalent times 100%, so 0.0625 times 100%. We're going to move that decimal point 2 places to the right, and so now we have 6.25%. So 25 is 6.25% of 400. So when a percentage is supplied in the data, then it may either be a number percent, like 25%, or it may be a percent with a label attached to it, such as 25% potassium chloride by mass. And let's examine each of these cases separately. If a number percent is supplied as data, then you can calculate using the rule X percent of Y means X divided by 100% times Y, or the decimal equivalent of X percent times Y. For example, 3.8% of 12,000 grams is what mass? Well, 3.8% of 12,000 grams equals 0.038 times 12,000 grams, which is 456 grams. So if a percent is supplied with a label, then we can simplify our calculation by methodically listing the wanted and the data, converting the percentage to its fraction, and then that fraction can be used as a conversion factor. So most equations and conversion calculations require the percentage to be converted to its fraction or its decimal equivalent. So unless an equation specifies that it uses a percentage, you want to convert that supplied percentage to a fraction by writing in the data one of these two. Either X percent means X units of the part per 100 units of the total, or X percent means the decimal equivalent units of part per 1 unit of total. Now, remember that per means the slash or equals, and that slash could mean one thing over the other. So per statements can thus be used as conversion factors. They are ratios. For example, in a potassium chloride solution, 2% of the total mass is potassium chloride. How many grams of potassium chloride are in 150 grams of solution? Well, we want mass of potassium chloride, we want grams of potassium chloride. The data that we have is 2.0 grams of potassium chloride equals 100 grams of solution. And 150 grams of solution was what was given to us. And that means now we can write our solve. So grams of potassium chloride equals now our given 150 grams of solution. Remember, we want a single unit, so we need to start with a single unit. And 150 grams of solution is the only single unit we have. And now we can get rid of grams of solution and get to grams of potassium chloride. So get rid of grams of solution. Now we have grams of potassium chloride. That's the unit that we wanted. And we then have 150 times 2.0 divided by 100, and that gives us 3.0 grams of potassium chloride. So that was fractions and percentages.